This is short video explaining charge transfer algorithm used to detect user's finger. Here is the schematic of our hardware. Here Cx is the capacitance of pad we have to measure, and Cref is a reference capacitance used to implement charge transfer function. Here is algorithm. First, we will discharge both capacitors, putting 0 onto both A and B pins of microcontroller or FPGA or whatever. After that, we switch pin B to high Z state, therefore disconnecting it from everything. After that, we put 1 to pin A. Therefore, we will charge Cx to power supply voltage. After that, we will again put both pins to high Z state. And after that, we will connect pin B to 0. In this way, we will connect both capacitors in parallel, and they will exchange their charge. At first, Cref is discharged, and Cx is charged, and Cx will transfer its charge to Cref. Since Cref is way larger than Cx, voltage increase just a little. After that, we again put high Z to both pins, therefore disconnecting both capacitors from whatever. After that, we will repeat this cycle. So, again and again, we will first charge Cx and then transfer its charge to Cref. Therefore, voltage at Cref will increase from one cycle to another. Once this voltage will increase to some threshold, and therefore we can count all these cycles, and the larger Cx is, the less count we will have. When there is no finger, count will be large. When there will be a finger, capacitance of Cx will be increased, and this will require less cycles to charge Cref. Now let's see to implementation at oscilloscope and whatever. Here is our hardware setup. This is my breadboard. This is my touch sensor. It's perfect. It consists of red plastic of thickness 3 millimeters to get my finger out of it. Here is at oscilloscope we see charge transfer implementation. Let's take a closer look. So here we can see that cycle after cycle we will charge Cx, and then at every cycle voltage at Cref increases a little. It increases, and once it reaches threshold of inner Schmitt trigger, which is inside microcontroller. Now I will touch my touch sensor this way, and let's see at oscilloscope. This is what I do what happens when I touch my touch sensor. We can see that now when I am touching the touch sensor, it will require way less charge cycles to reach threshold. I can increase sensitivity by disconnecting oscilloscope. Now, for now, we can see that there is this amount of cycles to reach threshold. When I touch my touch sensor, count decreases. Now I will disconnect oscilloscope, therefore capacitance of oscilloscope probe will be removed out of scope. So now we have way more cycles to charge our 0.1 microfarad capacitor. But sensitivity of all this system will be increased. Now when I put my finger near the sensor, we can see changes of count needed to transfer all charge to our reference capacitor. When I touch my touch sensor with both fingers, we see dramatically that count decreases dramatically. That's all. Enjoy.